The next subtopic is zeros, roots, and factors. So a zero of a polynomial is the value of the variable which makes the polynomial equal to 0. So in the previous slides, we discussed about what a polynomial is. So a 0 would be a value that would make the polynomial equal to 0. So if alpha, which is a Greek symbol, is a 0 of the polynomial, then p of x, this implies that p alpha equals 0. So this is obvious because we usually equate a polynomial to 0 in order to find the solution or the 0 of the polynomial. So if you substitute the value of alpha into p of x, then you'd get 0 because alpha is the 0 of a polynomial. So the next is the roots of a polynomial equation are the solutions to the equation. So this is very similar to the previous one, except a 0 is related to a polynomial and a root is related to an equation. Both of them are the same concepts, but we usually call the solutions of an equation as roots and the solutions of a polynomial as a 0. So similarly, if alpha is the root or the solution, then p alpha equals 0. And yeah, so the roots of p of x equals to 0 are the roots of p of x and the x-intercepts of the graph of y equals p of x. So basically the value of y becomes 0, right, when we try to find the solution. So essentially what we're trying to do is making the value of y equal to 0, meaning that we get certain values of x. So therefore we get the x-intercepts of the graph as the solutions or the roots of the equation. The next point states that x minus alpha is a factor of p of x. So if that is true, then there exists a polynomial q of x such that p of x equals x minus alpha times q of x. So that's pretty simple. So let's move on. Let's try to solve some questions based on zeros, roots, and factors. We've already done this in the quadratics chapter, so this is just going to be extra practice. So over here, we have a quadratic function. We could use the formula x equals to minus b plus or minus square root of b squared minus 4ac whole divided by 2a to solve the question. So minus b would be 5. So plus or minus 5 squared is 25. Minus 4 into 2 into negative 12 divided by 4. So this is going to be 5 plus or minus 25 plus, this is 48 into 2 would be 96 divided by 4. And now using the calculator, I'm just going to find this. So this is 5 plus or minus square root of 121 divided by 4. And square root of 121 is 11. So we can write that. Therefore, the solutions or the roots of the equation are minus 3 by 2 and 4. So these are the solutions of this equation. So now let's equate this to 0 and solve it. We're trying to find the roots. So we can take x as common. So x times x minus 2 minus 4. So we can use the formula a squared minus b squared equals this would be x multiplied by x plus 2 times x minus 2 equals to 0. So x equals 0, x equals minus 2, or x equals 2. So that's our solution for this question. And then so this is our next question. So we're supposed to find the roots of the equation. So first we'll equate this to 0. We get x equals 1 by 3. We got to equate this to 0. So let's do that. By splitting the middle term, we get x plus 3 times x minus 2 giving 0. So x equals x plus 3 equals 0, implying that x equals 3, or x minus 2 equals 0, implying that x equals 2. So therefore x equals 1 by 3, x equals minus 3, and x equals 2. Okay, moving on, let's solve this question, this one. So let's rearrange this. And now let's use the quadratic formula. Or we could just use the splitting the middle term because that's easier. So we'll plug this back into the equation to see whether we're right. So 5 into 1 squared minus 3 into 1 minus 2 equals what? So this would be 5 minus 3 minus 2, which is 0. So this is right. Now let's put minus 2 by 5 into the equation. So which is indeed 0. So the solutions are right. And now let's equate this to 0. Let the equation be this equals to 0. So in this case, you cannot directly solve it. We have to make a substitution. So let x squared equal to z. This is done to make sure that we get a quadratic equation instead of the one with a degree 4. So let's do that. So this would be z squared minus 6z plus 8. Over here we can split the middle term into -2 and -4. On multiplication we get 8. So we can use this. So we get z squared minus 2z minus 4z plus 8 equals 0. And then we can factorize it. You may think that we're done right now, but that's not the case. We have to find it in terms of x because our original equation, this equation, was in terms of x. So we know that z equals x squared. So upon substitution, we get this. So x equals plus or minus square root of 2, or x squared equals 4. That means x equals plus or minus square root of 4, which is 2. So plus or minus 2. So the roots are root 2, minus root 2, 2, and minus 2. These are our roots to our equation x to the power of 4 minus 6x squared plus 8 equals 0. So now that we've solved all these 5 questions, I hope it's clear. Yeah, moving on, let's talk about polynomial equity. So when two polynomials are equal, if and only if they have the same degree, which is the exponent on the variable, and the corresponding terms have equal coefficients. So this is the polynomial equity rule or a statement. So now let's look at this example. So we have to find constants a, b, and c given that this statement is true for all values of x. So what you have to learn from this is that if the variable has the same exponent and there is an equal to symbol in between, you can basically, when you simplify this, whatever coefficient is next to the x cubed term, you can equate it according to this rule. Let's look at the worked example to ensure that this concept is quite clear. So we have this statement. So find constants a, b, and c given that this polynomial is equals to this for all values of x. So our first step would be to expand this. So upon expanding, we get a polynomial stated below. So yeah, and then we have to simplify it. We have to basically add like terms together and subtract like terms to ensure that it's simplified and it's in decreasing order of the variables on the exponent. So now we have this statement. So now we have 6x cubed equals to this. For now, we'll just consider this. So therefore, we can equate these two because they have the same degree. So upon equating, we get a equals 3. And then what we can do next is find the value of c, because it doesn't have any other variable related to it, in the sense it doesn't have multiple variables to solve for. So we first find the value of c, which is minus 7, and then we can equate 2b minus a to 7, and we already have the value of a, so we can substitute that. So it would be 2a minus 3 equals 7. So it would be 2b equals 10 and b would be 5. So you can also check in this and you'll still get 5. So that would be minus 19 equals 2c minus b. C is minus 7, so we can write minus 14 minus b equals minus 19. When we put this to the other side and take b to the other side, we get b equals 5. So we get b equals 5 in both equations, implying that we are indeed right. So we can finally state that a equals 3, b equals 5, and c equals 7.